Hey there, welcome to another edition of Kung Fu Physics, where we are working our way presently through Physics GRE practice exam problems. I have for you number 5 off of the 1986 exam. It looks like this. Another mechanics problem. Probably a little fuzzy to read the older editions of some of my printouts, so if you have it at home, you might want to get it out. But I'm actually doing this problem cold. This is basically my first take for this, so we'll see where I get with it. I read the problem and it seems easy, so let's do it. As always, I'll check the answers there. And it's just fractions of something called h naught is what I'm going to be picking out of, so that's fine and good. Let's read the problem. Number 5, two small spheres of putty A and B of mass M and big M and 3 times big M respectively hang from the ceiling on strings of equal length L. Sphere A is drawn aside so that it's raised to a height of h naught as shown above and then released. Sphere A collides with sphere B. They stick together and swing to a maximum height h equal 2. Okay. So, when you see a problem like this, you're probably tempted to, hopefully, you're tempted to think about using conservation of energy principles and or conservation of momentum. It would be a mistake in this point, at this problem, to just set up a flat, straight across big M G H naught as being my initial potential energy equal to 4m, the total mass, GH. That would be a mistake. I'm pretty sure one of those dummy answers will let you answer that. Yeah, it looks like answer C would be, this would lead you to C. The reason is that the energy is not conserved. The energy is not conserved. Energy is only conserved in a collision if it's an elastic collision, right? This is not an elastic collision. The two things are sticking. Physically, if it helps you remember it, when something sticks like that, you're going to have thermal energy, stuff heating up during the collision. Energy won't be conserved in that collision. So I think that's the trickiest bit to this problem, is realizing that's not the case. So the way I envision this in my head is, I know the ball, I can use conservation of energy to get the velocity right before the first ball strikes the second ball, and then I can use conservation of momentum to get the velocity of the whole group afterwards, and then I can use conservation of energy again to get back up to the height. There. Makes sense in my head. Probably didn't describe that very well. But let's try that. So 1m times g times h naught equals 1/2 and mv squared. And so this is going to be the kinetic energy just before the collision that's present. And I want to get the velocity. Whereas that potential energy of the first ball has totally been converted. And so what is my velocity equal to, right? So I get 2 v equals 2gh. Okay. So then I want to do that and what I'm going to do here is, this is my momentum initial, and I'm going to set that equal to momentum final, and this is during the collision. Okay, so this is I calculated this velocity, so m times v, this is all my initial momentum, and then the final momentum is going to be another velocity. I'll call that v prime, and that's of the two balls stuck together. They're going to move at another velocity. And so the mass is going to be 4 times as much, and then I'm going to get a v prime in terms of all that other crap. And so v prime equals root 2gh over 4. Great. Okay, now I use conservation of energy because I know this is the velocity of the two balls and they're going to swing back up together to another height. So basically I get 1/2 m, and in this case it's going to be 4 times big M times v prime squared. And so I'm going to square this as I plug it in. And that is going to be equal to 4m g h. And I got a little sloppy there. This should be an h naught all through there. My bad. Okay, this cancels out, right? 2 times 4 is 8, times 2 is 16. Oh, thank goodness. Oh, no, it doesn't cancel out. 2's cancel out, the 4 cancels out, leaves me a 4 on the bottom there. So I get mgh over 4 is equal to 4mg h naught. G's cancel. And then I get h naught. Well, I get h equals h naught over 16. You see that? Hopefully you can see that. And is that one of my answers? Yeah, it looks like answer A is what I want conceptually. Does that make sense to me? I think it does. I think it does. That height's going to be quite a bit smaller. So I would go with answer A. And as I said, that was kind of my first take. I'm not able to do these problems on a first take usually because not because I was solving it wrong or something. I solved the problem. A lot of times I'll do it before. And then the retakes usually come from when I misspeak and I say angular velocity instead of angular momentum or something stupid like that. And I usually end up doing a lot of retakes. By the end, they're a little bit more polished, of course. In this case, I don't even know if that's right. So I'm going to stop the video and go check with the other answers and hope that I did this problem right. And that's that. If not, I'll be doing another take. So hopefully I got lucky with this one. And thanks for watching, and I'll catch you next time.